Good evening, everyone. I am Ankur and I am researcher at Council on Energy, Environment and Water. Today, on the behalf of the contributors to this research, I'll be presenting on implications of changing global natural gas dynamics on India's ambition of being a gas-based economy. CW is among Asia's leading policy research institutions. We work across 7 focus areas and have a dedicated center for energy finance. Coming to the key components of the presentation today, natural gas is one of the big bets for achieving sustainable energy future in India and holds global relevance as well. We already have a vision in place to achieve 15% natural gas in primary energy mix by 2030. But we have seen in the past that the growth has been slow in the natural gas adoption from 5.6% in 12-13 to 6.2% in 2018-19. Inadequate infrastructure, high prices of gas, and some inherent characteristics are the key reason behind this slow growth. One of the inherent characteristics is the gas allocation policy. The policy classifies these sectors into two tiers, which is prioritized and non-prioritized sector. The prioritized sector is subjected to the cheaper domestic gas, whereas the non-prioritized sectors have to rely on expensive LNG, which is one of the hurdle in adoption of gas in those sectors such as industries. But recently, we have seen that there is a significant decline in global LNG prices, which could offer an excellent opportunity for India to adopt gas in across the sectors. But with increasing gas share across the sectors, another component of gas debate, which is the role of natural gas as a transition or bridge fuel in decarbonization, becomes really relevant. Considering all the key components of the natural gas debate in India, we reach to our first and major question, that could India become a natural gas-based economy? This is a very overarching question. To answer this, we have 4 sub-questions planned across the study, which are: how would natural gas penetration evolve across sectors under high and low gas prices? What would be the implications of removing gas allocation policy regime? Does high gas penetration impedes India's progress towards a low carbon economy? And what are the monetary and non-monetary benefits of being a gas-based economy in India? To answer this question, we use a global change assessment model, which operates on an integrated assessment model framework and represents the interaction between the 5 major sectors. In the energy sector, electricity generation, industry, building, and transport are some of the relevant sectors for the natural gas adoption in India. Coming to the scenario framework, so we explored 4 scenarios in the study. For each scenario, the key variables are prices, infrastructure improvement, and gas allocation policy. The first scenario is the high gas price scenario, which is also the reference scenario for the study. The scenario assumes that the high prices which India faced previously will be persisting in long term. And since there are a lot of investment coming in for the infrastructure improvement, so we have actually introduced an infrastructure improvement also in this scenario. At the same time, we have assumed that the gas allocation policy will be present, which simply implies that the non-prioritized sectors will be facing relatively higher prices as compared to the prioritized sectors. On the other hand, the low gas price scenario represents the shift which I was talking in the background, that recently we have seen the global energy prices going down, and this scenario assumes that the low gas price will persist in a long term. And we have kept the infrastructure improvement same because to actually rule out its influence on the gas share, so that we understand what is the implication of the gas prices. The same gas allocation policy is considered in this scenario also, which implies that overall there will be low gas prices, but still non-prioritized sectors will be facing relatively higher price as compared to the non-prioritized sectors. The third is the uniform pool price, which is an alteration to the low gas price scenario. In this, we considered that the gas allocation policy will not be there, which implies that all the sectors across the economy will be facing one price of gas. And the fourth one is the carbon constraint scenario. In this, we applied 2-degree carbon constraint on the high gas price and low gas price scenario. In this scenario, also infrastructure improvement and gas allocation policy is considered. Across all the scenarios, we explored 3-4 variables which are mentioned here, which is natural gas adoption across sectors, emission reduction, import bills, employment, etc. Now, coming to the results of the study, the first question is, will India be meeting its proposed target of 15% natural gas in 2030? So the simple answer is that target will be missed in both high and low gas price scenario. But interesting fact is, that the margin by which it will be missed in low gas price scenario will be just 2%, because the gas share rises from 6% to 13%. Whereas in long term, by 2050, natural gas could support nearly one-fifth of the total primary energy requirement, which majorly replaces coal and oil. In addition to the primary energy, gas across sectors is also a very relevant factor. So we can, in general, we see that in low gas price scenario, natural gas share increases significantly across all the sectors. But the share of gas in transport and industry sector gets nearly doubled. And industry being on a non-prioritized list showcase great potential of adopting gas in low gas prices scenario. Whereas in power sector, we see negligible change because gas remains uncompetitive as compared to the other sources of generation such as solar, which is also likely to have a lower cost trajectory in future. Considering the third scenario, which is the uniform pool price scenario, the overall gas share in the primary energy mix will be declining by 2% as compared to the low gas price scenario. The reason behind this decline is that the prioritized sectors will be losing their special status and will have to face the high price of gas, which is a uniform pool price for all the sectors, which impedes the adoption of gas in those prioritized sectors. With increasing gas share, the question comes to that will it be affecting the decarbonization efforts? So for that, we have seen CO2 emissions and carbon price. So in CO2 emissions, we see that the high gas price and the low gas price, both the scenarios will be having more or less similar trajectory. Hence, there is not much difference in carbon reduction even with the high gas penetration. Whereas if we apply a 2-degree carbon constraint, the emissions peak in 2030 and decline significantly by 2050 to restrict themselves in the budget applied. On the other hand, the question comes, if the emission reductions are not enough, then will it be making difficult for decarbonize the economy? Then from the carbon price scenario, we also see that the trajectories in the carbon price are also more or less similar, which implies that the increasing penetration of gas in the Indian economy won't be making it difficult, neither easier to decarbonization, hence negligibly changes the effects. But we see that to actually supply so much of gas to the consumer to meet the increased demand in the low gas price scenario, there will be a significant infrastructure deficit, and which requires huge investment. Some are coming, but more to come. But when we applied the 2-degree kind of carbon constraint, it again pushed back for the reduction in gas share, and that pushback will result into the stranded assets, which are presented in the figure on the right top by the red dotted lines, that there will be stranded asset in case of the 2-degree carbon constraint. Nevertheless, being a gas-based economy will have a lot of other benefits. One is about the employment, which is also a relevant factor for developing countries like India. Nearly 1.4 new employment opportunities could be generated in gas infrastructure value chain by 2050. Whereas in terms of economic gain, which is import bill, we could have a 46% reduction as compared to the reference scenario, which could be to the magnitude of 723 billion. We have already seen in terms of emission, the emission reduction is very less, but still it is 2.8% as compared to the reference scenario. Based on all the results which I discussed till now, there are few conclusion and policy implication we can reach to. The first one is low gas price could offer great potential for natural gas uptake, but there is a significant need to expedite the gas infrastructure to actually tap in this opportunity. At the same time, the low gas price could lead to a significant 1/5 share in the primary energy mix for natural gas, but there is a risk of stranded assets. That's why we suggest to achieve an optimal point, nearly 17%, so that we can keep on gaining from the low gas price opportunity while avoiding the stranded asset at the same time. In terms of gas penetration, we have seen that the withdrawal of gas allocation policy won't be a beneficial move. But existence of this policy is associated with multiple nuances depending on the consumer sectors they actually prioritize, which requires further exploration to comment further on it. And at the last, high gas penetration under low gas price scenario will be really helpful for India in reducing the import bills as well as generating employment opportunities, whereas the emission reductions won't be much. Thank you for being patient, and would be happy to answer your questions.
That was a very fast tour through a lot of research. and I'm sure that there are questions. Please put them into the Q&A. And in fact, we have our first question emerging here. What modes of transport experience the greatest uptake of natural gas, and can we account for methane leakage?
Okay. Talking about the transport sector, in the short term, modes like in passenger four-wheelers would be a greater, you can say, consumer of natural gas. But India also planned for a significant adoption of LNG in trucks, and have already planned some thousands of stations, and actually looking forward for trucks. So in long term, we also see trucks to be a significant adopter of natural gas. And talking about the methane leakage, since India is like methane leakage is definitely a big problem for natural gas in the economies like USA. But economies like India has much of a newer infrastructure, which is still in the development phase. So we don't see methane as a big issue in our shorter time period till which we have looked at, because the infrastructure is relatively very new and is not likely to face these things. And even some practical test on some LNG terminals, which are relatively new in India, has seen that there is approximately negligible gas leakage. So methane leakage won't be a problem for India in a shorter term for this study.
Great. And the other sort of complementary question to that is, are you reducing methane emissions from coal as natural gas penetrates into the market, replacing coal?
For this study, we haven't really looked at the methane emission. So we restricted the emission, you can say emission scope till CO2 emissions, because they are relatively much more specific to the energy sector. That's where we are looking at for the aim to achieve India as a sustainable energy future. But definitely, it's something to be looked at.
Great. Thank you very much. If you other questions occur to you, please put them into the Q&A. And if we have a few minutes at the end, we'll begin to take those back up.
Sure, and I'll keep on responding in the Q&A section itself.
Great. Thank you very much.
Thank you, everyone.
Let me now, we have our second presentation this, to me it's this morning, I guess to many of you it's this evening or this afternoon. And it is on low carbon transition pathways for China under a 1.5 degree climate target. And Yin's going to make the presentation this morning. And so, Yin, are you ready to share your screen?
Okay.
Thank you.
So I'm going to start. Hi, everyone. Good morning, good afternoon, and good evening. My name is Mingjian, a graduate student from Tsinghua University. Here I'm going to introduce our recent study on low carbon transition pathway of China under the 1.5 degree climate target. So, ever since the IPCC 1.5 special report published, there has been a lot of research on the global 1.5 degree pathway, but there are limited research about national pathway of China. And also on September 23rd, the President Xi announced at the United Nations the target of achieving carbon neutrality by 2060. And it has aroused widespread concern about the meaning and of the target and itself and its relationship with the 2 degree and 1.5 degree climate targets. So in this context, this study mainly focuses on the analysis of China's 1.5 degree scenario pathway compared with that of the 2 degree target and also the 2060 carbon neutral target. And This study applied the PACE-LEO, which is a simulation model developed on the LEAP platform. This model has a very detailed representation of China's energy systems, covering on the edu sectors, and will also further dividing each sectors according to the China's energy consumption. For example, in the building sectors, it was divided into urban resident, rural resident, northern urban heatings, because heating in the northern towns accounts for nearly 1/4 of the total energy consumption of buildings. So we separately model it to analyze its emission reduction potential. The model also considers the upstream of end-use sectors, such as the demand for the industrial materials with the growth of building area, road mileage, car ownership, and so on. So we can better simulate the future growth of energy service demand in this process. Well, the transformation model is composed of power generation, heat production, and also hydrogen production in the 1.5 scenarios. There are 10 types of fluids and 37 types of power generation technologies modeled in this part. And besides the structure, a database with technical and cost parameters for about total 435 types of technologies also developed. So we can calculate the corresponding mitigation cost and the investment requirement. So next comes to the emission pathway comparison. So for NDC scenarios, it requires an emission peak around 2030, and under the 2 degree and 1.5 degree scenarios, the peaking time will be advanced into 2020. And also to achieve the 2 degree target, emissions need to be reduced at a rate of about 2%, and it will reach 3 billion tons in 2050, which is about 1/3 of the 2015 level. Under the 1.5 scenario, it comes with an average annual rate of 3%, and the emission will only be half billion tons, and it's only 5% of that of the 2050 level. For sectoral pathways, the peak time of 1.5 scenario is consistent with that of 2 degree scenarios. And for industry, power, and building sectors, they will all reach the peak in 2020 because for transport sectors, because the vehicle ownership will still have a high growth potential, the emission will continue to increase and reach the peak in 2025. In mitigation, most of contribution of emission comes from the industry and the power sectors, and under the 1.5 scenarios, a deeper mitigation is required after the peak. The power sector has the largest contribution, and it will also achieve negative emissions after 2048. For industry sector, additional emission reductions between 2 degree and 1.5 degree comes from the hydrogen replacing coal in producing high temperature heat and feedstock. Also, efficiency improvement from the ICT application such as 5G and big data could help in this process. The largest mitigation potential in the building sectors really comes from the northern urban area heating, with coal substituted further by electricity, heat pump, and a few hydrogen mixed with natural gas. And in the building sector, the improving electrification and solar utilization in water heating and cooking will are also required to reduce emissions in both urban and rural residents. Well, in the transport sector, the further flue shift away from the oil is the key to the lower emission. Also, the biofuel used in navigation and aviation, the hydrogen utilization in the heavy road transport helps in this transition. Last, in the power sector, the power sector will contribute the largest part to emission reduction, and during this process, the BECCS is very crucial to realize the negative emissions in the power sector and also to offset emissions in other sectors. And it also should be noted that the increase of electrification rates from the demand side will also increase the electricity demand. So this part of additional emissions was caused from this reason. Next comes with the key outcomes of 1.5 degree pathways. First, for the primary energy consumption. In 2030, compared with NDC targets, the non-fossil fuel ratio in 2 degree and 1.5 degree will increase to 30% and 34% respectively. And by 2050, the proportion will increase further. The consumption of non-fossil fuel energy will exceed that of fossil energy, accounting for about 16% in 2 degree scenario and 70% in 1.5 scenario. In edu sector, the electrification rate will increase significantly in both 2 degree and 1.5 scenarios, from about 20% in 2015 to about 13% in 2030, and finally about 50 in the 2050. More than half of the edu energy supply in the 1.5 degree scenarios will come from the electricity. In the 1.5 scenarios, biomass and hydrogen will also play increasingly important roles in the long term, with their proportions reaching about 10% and 5% in 2050. With the increasing electrification, the electricity demand is also greatly increased. So under the 2 degree and 1.5 degree scenarios, the total capacity in 2050 is more than doubled compared with that in 2030. The 1.5 degree pathway requires the phasing out of coal-fired power plant without CCS technologies. While the non-fossil fuel power generation technologies will dominate power system in the long range, the capacity of wind and solar power will both reach around 2,000 gigawatts in 2050. And between 2030 and 2050, the average annual capacity addition of wind and solar power will both be about 115 gigawatts every year. Besides, the BECCS technology, BECCS capacity will also reach about 353 gigawatts in 2050, and it will bring the negative emissions in this sector. So for the net zero 2016 targets, we take current policy and action progress into consideration, and we assume that the feasible pathway will peak the emissions in 2025, and then it will rapidly decline until it reaches the carbon neutral in 2060. With the later peaking year in the 2016 scenario, all sectors can have their emission peak 5 years later compared to that in 2 degree and 1.5 degree scenarios. So it is more feasible on the practical side. However, after the peaking, the emission reduction rate will also be accelerated. And there will also be higher risk of carbon locking assets. For example, if the peak time is delayed 5 years later, the coal-fired power plant and also the flue vehicles will continue to be added in this period, during this period, and the risk of early elimination will occur in the future. And our future study will further compare the mitigation costs and the economic impact among scenarios. So that's all, and thank you for your attention.
I see that we have a for you in the Q&A. I wonder if you might want to comment on this question. It says, will the commitment to national carbon neutrality in 2060, in your opinion, also settle discussions on clean coal in China in view of the time path required?
Well, I can't hear you very clearly, so could you please repeat again?
Yes, it's over in the Q&A. So if you click on Q&A,
okay.
You'll see this question that is from Jan that says, will the commitment to national carbon neutrality in 2060, in your opinion, also settle the discussion on clean coal in China in view of the time path required to meet the 2060 target?
Well, I think definitely the carbon neutrality in 2016 will require cleaner coal power plants in China. So it also will face phasing out risk because it will have a delayed peak time in about 2025. So in the future, it also the phase out of coal power plant will definitely happen in this scenario.
You also have another question from Helene that asks, thanks a lot for an interesting presentation. Could you say something about BECCS, which plays a key role in the 1.5 scenario? Can the required biomass be produced domestically, or are you counting on imports? And
so
the sectoral allocation will be available for both power. Oh, will the sectoral allocation be available for both power and for transport? So about bioenergy with CO2 capture and storage.
Okay, thank you. So in our study, we mainly use the BECCS technology in the power sector, and based on the resources supply of China. So I think it would be enough to be available for power sector. However, we didn't use the BECCS technology in transport. So we still need to further investigate in this problem, in this question.
Right. So I think the role of the bioenergy with CO2 capture in transport would be through the refining sector, where the bioenergy would go into refining. The carbon, the extra carbon would be removed, and either hydrogen or a fuel would be produced, a more conventional hydrocarbon fuel, and the net consequence of capturing that bioenergy carbon emission from the refineries would also be a negative emission. So I think that's the point of this division between transport and power. So let's now see if we can't get everyone, Ankur, back and just open up a general discussion. I see a question from Brian Mingjian back to Ankur that says, could you say something about the gas prices assumed in the high and the low cases?
Yeah, so I think I've replied in the question Q&A, but I would like to discuss here as well. The two scenarios which we have considered in our study is the high gas price and the low gas price. So high gas price, in the high gas price scenario, we assume that the LNG prices will be around $13 per MMBTU at the terminal of India, and there is a lower domestic gas price which is around $5 per MMBTU. And because, as I have discussed in the presentation, there is a gas allocation policy. So there is a pooling of these, you can say, LNG and domestic gas to actually in a proportion that prioritized sectors get a lower gas price. Hence, at the end, the sectors for such as city gas distribution and fertilizer gets a very low price as compared to the industry. But in lower gas price, we have assumed, and with the lower gas price, we also say that the share of spot will be increasing in India. Right now, India majorly rely on long-term contracts. But with the global LNG prices declining, there will be a potential for spot uptake. And it is already happening that we see in recent trends. So in the low gas price, we assumed $9 as a long-term contract price, which is one of the major industry has signed. And after as a spot, we have consumed $3 per MMBTU, and in the domestic production, it's $2.5 per MMBTU. And again, the pooling, because we have assumed the gas allocation policy would be existing in the low gas price scenario also, because it is there to safeguard some, you can say, sensitive sectors such as fertilizer, which actually take care of the farmer side, that they don't have to pay much for the fertilizer, or the city gas distribution, which is more important for the tackling the pollution like problems in the city. So after the in the gas allocation policy, all the three prices gets pooled, and again we see that there is a relatively higher price in even in the low gas price scenario. There is a relatively higher price for the non-prioritized sectors.
Thank you. There are a number of questions for Yin. I'll start with Atsushi Kurosawa's question. How much CCS is introduced in 2050? Industrial CCS is in steel, cement, and chemicals. So how much of the CCS is getting deployed over there in the industrial part of the economy, steel, cement, and chemical manufacturing?
I think I can't remember that exactly. I could, would you mind I find it later and reply it online through the Q&A.
Okay, great. So you can see there's a question from Urs Ruth. Yin, could you please clarify the official target of China? Is it climate neutrality of CO2 neutrality until 2060? So is this a net zero target for the year 2060?
Now on all the policies have not coming out, and we can only say that target from the President Xi talk in the United Nations. So here we did a lot of assumptions about this, and the main aspect is about the peak time. We assume it will following its increasing trade before the peak time, consistent with 2 degree and 1.5 degree scenarios. And after the peaking, we also give it a restriction, which is net zero carbon emission in 2060. So now we usually use the limited information, and we build these scenarios through such ways.
Great. Now here's a question for you that is one of everyone's favorite questions. Could you please say something about the future of nuclear in China?
Well, I have to say I'm not an expert about nuclear, but I can say a little about it. In China, the most energy used to produce electricity is coal, and in the future, I think it will this trade will further developed, and so the CCS technology is very important to China power sector, and also other negative technologies which could be applied into the power sector is also useful. So from the perspective of energy safety, China maybe pass through a very I say special period in the future. But I think that nuclear won't be the majority of China. It will only be a little part of the electricity power sector in China. So thank you.
That was a very diplomatic answer. I'm very impressed. So
thank you.
I think we have covered most of the questions that we have here. And let me just sort of peruse this. I think we've gotten to all of them. So, and we only have just a few minutes left in our session before we have to depart for our break. So let me just offer each one of our speakers an opportunity for any final words they might have for our session that they could offer to us. And let me start with Ankur. Can you do you have any final remarks that you would like to make for as we close out the session, and any sort of final thoughts about your work on natural gas use in India?
Yeah, so I would say that India is one of the major energy consumer and holds a really significant space in the global community as well in that terms. And natural gas is one of the big bets on which we are putting on for the you can have support the 4 pillars of energy, which is our efficiency, access, sustainability, and following that, maybe natural gas is something which is a kind of we have to make an informed decision for it. As study suggests that it definitely have a lot of you can say benefits in terms of employment, in terms of economic gains. But before giving it a full throttle, I think we should choose for an optimum point so that we doesn't end up having some stranded assets, because we have to do a lot in terms of decarbonization, and India is already thinking on its way towards a better low carbon economy. So I think we have to think of an optimal point for natural gas.
Great. And Yin, any final remarks?
Okay, so I think that now the most study are focused on the global transition pathways under 2-degree or 1.5 degree climate target, and national for us who are focusing on the national transition pathways. I think that we all need to communicate with each other, because we both have a very I think limited resources of information, and we could I think in the future we could communicate. I'd like to communicate with other researchers and to exchange our information and move on our research. Thank you.
All right, well, thank you. And thanks to everyone who joined this session. Thanks for those who put comments and questions into the Q&A. And thank you for a really good session. These are really two critical countries that need to be understood better if we're, as a planet, going to meet our 1.5 or even 2 degree goals going forward. So with that, let me declare the session complete, and thank everyone again, and we'll see you in the rest of the meeting. Take care. Thank you.